You are looking at a map of every tropical cyclone track between 1985 and 2005. If we zoom in on the North Atlantic basin, an interesting pattern becomes apparent. At lower latitudes, tropical storms have a strong tendency to move towards the northwest. Some of this motion can be explained by easterly trade winds pushing storms towards the west, but the northward component is curious. And it's not just the North Atlantic. The same pattern shows up in the Northeast Pacific, the Northwest Pacific, and in the Southern Hemisphere too, though in this case the motion has a southward component instead of a northward component. So why do tropical cyclones have a tendency to drift westward and away from the equator, all around the globe? Well, Earth's rotation about its axis imparts spin onto the atmosphere. A component of that spin is projected into the vertical axis with a magnitude that depends on your latitude. This spin is called planetary vorticity, and it increases with increasing latitude. The latitudinal gradient is largest in tropical regions, where the slope of this graph is steepest. Now consider a tropical cyclone in the northern hemisphere with a counterclockwise circulation. As we've just established, there's going to be a gradient in planetary vorticity across this storm, with smaller planetary vorticity to its south and larger planetary vorticity to its north. The air with smaller planetary vorticity is transported to the storm's northeast quadrant by its counterclockwise circulation. Similarly, air with larger planetary vorticity is transported to the storm's southwest quadrant. The air transported to the southwest quadrant now has more angular momentum than its surroundings, so a cyclonic circulation develops. The air transported to the northeast quadrant now has less angular momentum than its surroundings, so an anticyclonic circulation develops in the opposite direction. The two counter-rotating circulations now drive a northwest flow between them that contributes to the storm's forward motion. This effect is known as beta drift. Beta drift is generally a secondary contributor to a storm's forward speed, on the order of just 1 to 2 meters per second, yet it's enough to explain the patterns in historical tropical cyclone tracks.